Here we go. Our objective for today, I can multiply polynomials. Read together. 1, 2, 3. And we already started with this yesterday. Is that correct? In regards to multiplication, but we already started with polynomials already for a while back. That's why we don't need a Freyer model. We don't need a Freyer model, okay? Because we already know what polynomials are. Is that correct? Tell you never the definition for polynomials. It sounded like a tongue twister for someone. Monomials. Yes. Yes. So yeah, monomials, or the sum of difference of monomials, and then you got example, non-examples, and some hashtags. You don't need steps. We already have the steps that we wrote down. So I'm going to go straight to the practice. So check this out. Yesterday we were clear that when we multiply exponential expressions of the same base, just to rephrase and to revisit this concept, we add the exponents. Everybody there? Because for today's session, you're going to start seeing how some of your processes are going to start getting a little bit confused with the different properties that are going to see in one problem. So you'll see that right now. Check this out. We did this one, yes, and I showed you 3 different ways of doing it by using the tiles, distributive property, and area model. Then you did that one. Then you guys did these 2. Then we did these and these, and then we went to monomial times binomial. Remember that? And then at the end, I touched on what happens when we distribute to 3 terms, right? All right, so check this out. So let's get to, let me get to, not that one, to this one. Copy this one, please, example 3A. Just copy it. You don't have to do anything else. I'm going to go over this process, and we're going to still continue using distributive property and area model, okay? All right. All right, here we go. Writing utensils down. Look up to the screen. And please, pretty please, on this one, even if you start, like, your mind starts going elsewhere, stay focused, please, because I'm telling you, this is going to be one of those concepts that is going to carry out throughout the year, and if you don't get it right now, it's probably going to leave. All right, here it goes. Writing utensils down, look up to the screen. Everybody looking up to the screen? All right, good. Here it goes. So now I hope you notice that here we have, instead of having a monomial times a binomial, now we have a binomial, 1, 2 terms. You guys see that? Times another binomial, 1, 2 terms. Are we there so far? But we do know how to multiply a monomial times a binomial, don't we? So just imagine that this was a monomial. What do I have to do? Take this part away. Is it a monomial now? And do we know how to distribute that here? Yes, right? X times x and x times -2. Is that correct? So watch. I'm going to do that step first. So I'm going to start with red. So once again, when I ask you to copy, make sure you have your colored pens, because now we're going to be doing some processes, all right? Here we go. You'll get those in a little bit, but right now pay attention. Here we go. When I ask you to copy, I said. Here it goes. Look up to the screen. So I'm going to circle the x in red, and I'm going to distribute that into each of these terms. So what is x times x? X squared, okay? And you're just paying attention. You're not copying. I'll let you copy at the end. Focus, please. Next, what is x times negative? Is there an x here? No. So x times -2 is -2x. Are we there so far? All right. But we're not done. It's not a monomial. Now it's a what? Binomial. So what do we do with that for? We do it again. I'm going to box this one, and I'm going to distribute to these 2 again. What is 4 times x? 4x. What is 4 times -2? -8. Are we there so far? So check this out. For step 1, what I did, I multiplied. Is that correct? Did I multiply? Yes. And in that process, what happened to the exponents of variables? What did I do to the exponents? Let's see, x times x. What was the exponent here and here? 1 and 1. What did I do to the exponents? So you add. All right. Are we there so far? So that's step 1. Now check this out. Here goes step 2. For step 2, I'm going to combine like terms. And what does that mean? That I'm going to add terms. So let's start with this one. Let's see. Is there another x squared? No. I write this down here. Okay. Is there another x by itself? Yes. All right. So watch. Aren't these the same? Yes. And now I just focus on the coefficient. Negative 2 plus 4, that's positive 2. Now before I continue any further, did I do anything to the exponents of these two? No. So when we add, don't add exponents. Because your brain is going to start trying to play those tricks on you. It's going to want to add again. Does everybody see that? So check this out. Don't add the exponents, you just combine. Are we there? And the last part. Is there another constant? No. Just bring that down. So question, can I combine anything else here? No. And I'm done. Copy that, please. All right, here we go. So the next part right here underneath, I'm going to write area model. Area model. Okay. So what process did we use here? What is this called, everyone? Distributive property, right? Distributive property. Now, the book and other teachers might introduce it, and they're going to call it the FOIL method, just in case you see it in the book or in case you hear it later. They call it the FOIL method. Yeah, FOIL means, like the aluminum foil. Yeah, like that. And the acronym means the process that we just did. But I don't want to get you into that right now. We'll talk about it later. I just want to make sure you understood the distributive property. Everybody understand? All right, let me go to the area model. For the area model, I want you to draw a rectangle, kind of big, like so. All right. So what is my first binomial? X plus 4. So check this out. Instead of writing it like this, I'm going to write it from top to bottom. X plus 4. Are we there so far? Now check this out. Where does this monomial end? Look up to the screen, please. Where does this monomial end? Right here. Is that correct? So watch. Whenever I see that the monomial ends, I'm going to draw a line across. Okay, let's write the other binomial. We're going to write it at the top. What is the other one? X minus 2. So where does this one end? Right here, and we're going to draw that one down. Everybody with me so far? All right, so here we go. Circle the X with red. And we're going to find first this area and this area. So check this out. What is X times X? This one is an X squared. What is X times negative 2? Negative 2X. So we're done with these two because of this one, right? So now we move down to these two because of the 4. So I'm going to box the 4 with blue. So what is 4 times X? 4X, and it's a positive. What is 4 times negative 2 again? Negative 8. All right. Now check this out. I like the area model because of this purpose. Writing utensils down, look up to the screen. You'll finish copying right now. Check this out. I like it because from here, check this out. All I have to go is go diagonally like this. Here I bubble these and I call this like my peanut. It's like a little peanut. Do you guys see it? Because these two can combine. Do you guys see that? And this one is by itself. Okay, so check this out. What is the first term? X squared. What is 4x minus 2x? 2x. And what's left over here? Did I get the same thing as this? Yes. Copy that, please. See how that flows really well? Yes, Mr. Q, we love these. All right, good. All right. So, any questions with the two processes that we're going to look at? No, right? So, I'm going to have you do this next one by yourself. See if you can do that both ways using distributive property and area model. Example Q. I want you to multiply parentheses y plus, give me a number, 8, close parentheses, open parentheses, y minus number 5. All right. So I want you to find me the product of that using the distributive property and area model. Ready? Go. I'll leave that up there so you can have it as a reference. All right, here goes the process one more time. I'm going to start with red. Y times y, that is y squared. Focus. Y times negative 5, that's negative 5y. From there I box the second term and I multiply it again times these two. 8 times y, that's positive 8y. 8 times negative 5, that's negative 40. Hands if you got it to right there. Good. Now we're going to combine like terms. Is there another y squared? No. Is there another y? Yes, right here. Since they're the same, I just write it once and I focus on the coefficient. We don't do anything to those exponents now. Bless you. Negative 5 plus 8, that's positive 3. And then at the end, bring down the negative 40, and we're done. Hands if you got that. Okay, good. Area model. Here goes the area model. Y plus 8, y minus 5, 1 across, 1 down, and once again, y times y, y squared, y times negative 5, negative 5y. From there I go with this one, 8 times y, that's positive 8y, 8 times negative 5, that's negative 40. I bring the first term down, which is y squared. I draw my peanut. There it is. 8y minus 5y, that's positive 3y. And then bring down the negative 40. Did I get the same thing as here? Yes. And make sure you practice these because these are coming in the next part. You have to do it both ways. Okay? Let's do another one. Copy this one. Example 3B. Example 3B reads parentheses y minus 4, close parentheses squared. Just copy it because this one has a little curve on it, and I'm going to show you what that is. Here it goes. Look up to the screen. Now, at first glance, your noodle wants to do this. Look up. It wants to do this. Right? That we cannot do because there's subtraction. That only worked when there was just multiplication. Therefore, if that's not working like that, then what do I do? Well, let's rewrite it. This says to multiply whatever's inside how many times? Twice. So I write y minus 4 times y minus 4. Do we know how to do this kind of multiplication? Copy that and finish it off, please. Bam. All right. Let's see. Here goes the process. I'm going to start with red. What is y times y? Y squared. What is y times negative 4? Negative 4y. All right. Second term. What is negative 4 times y? Negative 4y. What is negative 4 times negative 4? Positive 16. Okay. Let's see. Do we have another y squared? No. Is there another y? Yes. I can combine these, so I write y. What is negative 4 and negative 4? Negative 8. That is correct. And then just bring down the last part. Hands, have you got that by yourself? Okay, good. Now be careful. Some of you subtracted negative 4 and the 4, and you got 0. Is that correct? Careful with those. Now let me show you the area model, how it's set up. Don't copy this, please. So look, we have y minus 4. Look how I'm going to write it. Y minus 4. Now, why did I do it like that? Because when I write it here, some of you tend to forget that there's a negative sign there. Does that make sense? And the other one is y minus 4. Okay? So check this out. So y times y, y squared, y times negative 4, negative 4y. All right? Negative 4 times y, that's negative 4y. Negative 4 times negative 4, positive 16. And let's see. Bring this one down. That's y squared. Draw my peanut. Negative 4 and negative 4, that's negative 8y. And then bring down the last term, positive 16. Did I get the same thing as this? Yes. Copy that, please. I just wanted to show you how to set up when you have negatives on the first binomial. Does that make sense? Yes, Mr. Q, we love these. Good. Copy that. All right, let's continue. Example 3C. Copy this one. 8m squared minus n times m squared minus 3n. And we're going to do this one together. And we're only going to use this using the distributive property for this one, just for the sake of time. 8m squared minus n times m squared minus 3n. Everybody ready? Please stay focused, guys. I know this is a lot to chew on in the morning, but we do need to finish this, and we need to get through these. So stay focused, please. Here we go. So circle the first term with red, and let's distribute that. Here we go. Numbers times numbers. What is the coefficient here, Dione? 1. So what is 8 times 1? 8. What is m squared times m squared? M to the 4th, because we're adding the exponents when we multiply, yes? Let's go to the next term. What is 8 times negative 3? Negative 24. Are we there so far? M squared, is there another m over here? No, so we just write m squared. And is there another n? No, just write that one there. Did you ever see what I did right there? Okay, let's go to the second term. Box the second term. What is the coefficient here again, everyone? Negative 1. Very good. So what is negative 1 times 1? Negative 1. N times m squared. So I write it in alphabetical order. Which one goes first? M squared and then n. Okay? Negative 1 times negative 3. Positive 3. What is n times n? N to the second. All right. Let's combine like terms. Are there any other m to the fourths? No, so we write 8m to the fourth. Box this one. Is there another m squared n? Yes, right here. So I write m squared n. Okay, so now we just focus on the coefficients. What is negative 24 minus 1? Negative 25. All right, and then you just bring down the positive 3n squared, and we're done. Can we combine anything else? No, right? Okay. Are we doing all right? Okay. Let's go to the next one. See if you can do that one by yourself. You can choose whichever method. You can do it by area model or distributed property. You choose. You have 40 seconds. Example 3D. A plus 3 times A minus 4. Clear focus? A plus 3 times A minus 4. Copy that. 30 seconds. Answer, Monse, pick someone. Chris, what'd you get for this one? A to the second. Minus A. Minus 12. Hands if you got that. That is correct. Some of you wrote minus 1A. That's fine. You can show the 1 there. Okay? Pretty good? All right, so we get these, yes? Okay, let's get to the funner ones. Copy this one, example 4A. Example 4A. And let me zoom in so you can see it. Complete. Multiply x minus 5 times x squared plus 4x minus 6. So now we have a binomial times a trinomial. I know. Oh, snap is correct. Okay? So copy that, and instead of using distributed property, I'm going to use area model for this one. Okay? Here we go. So draw your rectangle, but I want you to make a bigger rectangle, a little bit longer than the other, like so. There it is. So what do we write on the height? We write x and what else? Negative 5 right here, right? And then we draw one line across, nice and straight like mine. There it is. And on top we write x squared, and then you draw a line down, plus 4x, draw another line down, and then minus 6. So what do you guys notice now? Now we have 3 different partitions for each top and bottom, right? So once again, to keep organized, let's start with red. Circle x. So what is x times x squared? X cubed. That's correct, Diego. What is x times 4x? 4x squared, and it's a positive, yes? What is x times negative 6? Negative 6x. All right. Go to blue. I'm going to box negative 5. What is negative 5 times x squared? Negative 5x squared. What is negative 5 times, let's see, 4? That's negative 20x. And what is negative 5 times negative 6? Positive 30. All right. Now check this out. Look up, please. I'm going to start with this first one. This one goes first always. So we're going to write what? X cubed. Now check this out. I want you to draw the peanut first for these two. So what is negative 5x squared and positive 4x squared? X squared. And it's a negative. Negative x squared, or negative 1x squared. I'm going to show it right there. I want you to draw a peanut for the second one. What is negative 20 and negative 6x? Negative 26x. And then at the end, we just bring down the last term, and we're done. It's what? Oh, yeah, I did that on purpose, see if you were paying attention. 30. Which method do you like better, distributed property or area model? Some of you like the area model, some of you like distributed because it's faster, but you can use either or. Everybody with me? All right, so your home play for this weekend, home play, is found on pages 514 through 515, and I want you to work on numbers 1 through 23, odds only. Have a good weekend, everyone. Enjoy your weekend. See you guys till Monday. Bye.